Good evening, all. Shubham, Sairam, Ruchita, good evening. Lucky, Harsh, Vivek, Rahul, with control. Transfer group, then arithmetic, then logical. Okay, so let's do some questions based on this. Then we can proceed for the branch group of control, branch group of instruction. So let's go. Let's go. Yesterday I have uploaded some DPP. I hope you have tried. Let's do that first. Then we can do more questions also. So this is not required because it requires branch instruction. So it is also branch instruction. This is not done yesterday or completed. It is done, I think. 10 came. This is done. Up to that we have done. This is to be done. Okay. Will you try? Shall we conduct the poll? Good. Let's try. In 8085 assembly language program is given below. Assume that the carry flag is initially reset or unset. The content of the accumulator after the execution of the program is. Okay, let us see what is the content. So, okay, let's try. Remaining people, let me give you some time. My dear Mark. Good evening, Chaitanya. Just give. I will give you 1 minute. So try. Fine. Good evening, Mark. So, are you ready? Sonali, ready? Remaining people, please comment. If you are ready, I can start the poll. Very good. So, let's start the poll. Nice. Wow. More percentage right answers. Let me take some water. Good. So, you can see the top 10. Mark, first one. Abhinay, Abhineet, Suraj, Sonali, Shubham, RK Singh, 3, and Nishita. Very good. So, let's see how to do it. First, accumulator is copied with 7. 7 means, okay. Rotate accumulator left. Rotate accumulator left without carry. But there is no use of carry in any other instruction also. All are RLCs and RRCs. So don't worry about carry much here. Here, rotate left without carry. Yesterday class I told you, if you say rotate left without carry, this last bit will be coming to the carry. Those story I told it. But as you are not using any carry in the instruction, forget about the carry. So easiest way to find rotate. What is the easiest way to find rotate is just shift left. Shift left means remove this bit and keep it at the last. Yesterday I told that. So remove this and keep it here. Then what will you get? 0, 0, 0, 0. Then triple 1, and that first bit will come to last. First bit will come to last. Okay. So it is hexadecimal, OD hexadecimal. Then B will be copied with OD. Then again rotate accumulator left 2 times. 2 times means this you take initially, what is this? 0, 0, 0, 0, double 1, 1, 0. I am doing it in the easiest possible way. If you say rotate accumulator left 2 times, what is the answer after this? Take these two, it is OE, na? Yes, yes, OE, right? So take these two and keep it other side. Then what will you get? 0, 0, 1, 1, 1, 0. That first 2 bits will come to last because you are rotating left. So this will give you 38. Then add B, that is accumulator is copied with A plus B, that is 38 plus OD. So 38 is 0, 0, 1, 1. Why to do that? OD. So 38 plus OD. 8 plus D. What is D? It is D or E? I'm sorry. Just wait. Yeah. It is E. OE. Okay. So 8 plus E, that will give you F and 1, 6, 1, 46. Very good. So it is 46 hexadecimal. Now again, 46 means 0, 1, 0, 0, 0, 1, 1, 0. Okay, rotate left or right. Right means what to do? Take this bit and keep it here. This is the right side. So what will you get? 0 will come here and remaining 0, 1, 0, 0, 0, 1, 1. So finally 23 hexadecimal. That's all. So there is no difficulty if you remember every instruction. It is the easiest thing. I already told you, no need to remember the instructions, what we call mechanically. You remember what we call logically. Just see the name, you should recollect it. Like that, you should remember. Good. So shall we move further? Yes. Good. Next question. Okay, we can do this. Try it. I hope everybody will do it. Accumulator is 45. B equal to 45. You forgot STC. Just use STC to recollect it. Rahul, wait here. Let him get out of that. I mean, let him get the answer on his own. Okay, ready? So if you want recollect, move immediately, move STC, set carry, complement carry, rotate accumulator right, X or A, exclusive or A and B, that's all. Okay, so let me check the answer once. 45, 45. Just 1 minute. Okay, so let's follow. Okay, good. I'm very happy most of you remember the instructions, are giving right answers. I think in this view, lighting is good, right? Okay, fine. So let's do it. It's not a difficult task. What happened? You people are not much active today. Anything wrong? I need some noise from you people. We don't like a serious class. Yes. Okay, 45 is copied in the first instruction. Move B, comma A. It's not Noida. Good. Always be on high. Set carry. Aditya, it is set carry which will make carry equal to 1. Yes, I will say stop talking definitely, but if you don't talk also, I feel lonely. Complementary carry. Complementary carry. That is, carry will be equal to 0. So rotate accumulator right. Rotate accumulator right. This is a simple instruction. So accumulator value is to be rotated right through carry. Through carry means here carry is 0, na? Through carry. Where is that? Yeah, 4. So see here, carry is 0. Okay. Carry is 0, 0, 1, 0, 0, 0, 1, 0, 1. Okay. So it is through carry. So right means this side. Is it mirror image for you? Yeah, at least up to some extent. Just like your WhatsApp, what you feel in WhatsApp, same I feel like that. Okay. So this bit will come here and this bit will go there. So 0, 0, 1, 0, 0, 0, 1, 0. That is 22 hexadecimal. Yes, you are seeing me. That is, I mean, you have more visibility. A equal to A XOR B. In networks also, I will open after from Monday onwards. From Monday onwards, I will open. Okay, because right now load is more, morning energy is less. Energy is less. It is not serious. Actually, it is what we call weak. Because see here, morning I am taking class, evening your batch I am taking, in between I am taking one session in YouTube. So little hectic is there because of sleep. Never scared to crack jokes. I am very happy for that. Oh, I take milk and take the breakfast. I mean, that is okay, but nothing can replace your sleep. Okay. Anyway, XOR A with B. That is, what is your B? Where is your B? B is 45. So take 45 here. Okay. Then XOR, simple operation. 1, 1, 1, 0, 0, 1, 1, 0. 67. Yes, Sura. Generally, I used to upload immediately after the end of this, what we call chapter, but this is long pending. So, what is this? 67. That's all. Okay. So, shall we move further? Good. So, let's move. Dad is there. This is not discussed, so don't do it. Yeah, let's do this. Let's do this question. So it is a two questions. This is the first part of the question. After the execution of line 7 of the program, the status of the carry and zero flags will be. Okay. After the completion of fifth, which instruction? Sixth instruction. You need to end immediately with 9B. Ready? Shall I start the poll? Upal? Okay, I will wait. I will wait. Okay, take your time. I am waiting. CPI is a party we discussed yesterday, na? Communist Party of India. You people told me what is CPA, CPM. Compare immediately. Compare immediately. Good. Ready for the poll? Let's start. Good. Nice. I increase the time for few people. Moving. Right, time up. So update the board, updating, it's updated. So here, number 3, 3 by 3 right answers. Mohan, Abhinav, wow, so many 3 by 3s, very good. So now you learn microprocessor completely almost. Abneet, Nishita, Subham, Anuj, Suraj, Danpal, and Rishi. Very good. Yeah. So here accumulator is copied with B5. Next, B is copied with OE. O means 0. E means 1110. XOR immediately A is equal to A XOR with 69. So do this. A is 1011, 69, 6 and 9. It is 0, 0, 1, 1, 1, 0, 1, 1. That is A, B, C, D, DC. Okay, so it is DC. Then add B. That is DC will be copied, added with B. B means 0, E. Add this C and E, you get A, 1 and E. If you are not comfortable with hexadecimal, just convert this into binary, decimal in your mind, add it. Or convert into binary and add your convenience. Then end immediately with 9B. 9B means 1001, B means 1011. This you need to end with EA. E means how much? 1110. A means 1010. If you do the end operation, any one of them 0, your output will be equal to 0. Okay, so it is 0, 0, 0, 1. That is 8A. Now you compare this immediately with 9F. 8A, that is your accumulator is less than 9F. Because of this reason, carry flag will be 1, 0 flag equal to 0. This we have discussed yesterday. That's all. When a accumulator is less than the new value, then you get carry equal to 1 and 0 flag will be equal to 0. Store accumulator, you need to store. Here no flags are affected in the store instruction. Program is done. Are you ready? Shall I move to the next question? Next question. Okay, let's go. Same question. This one is similar question, I think. Oh, actually, this is the first question. That is the second question, but slide it little. So this question, what is the statement? The contents of accumulator just after this. Already we have done now. We got EA. Next. This is not required right now. Let's do this. Let's do this. Let's see what is the right answer in this case. Let us see by Yashwant Kanitskar. Am I correct? You know it or not, that particular book? Right. So please try it. I will start the poll. So this program is starting from the memory location 0100 hexadecimal. The contents of accumulator when the program counter reaches 0101 is Are you ready? Shall we start? Good. Okay. So this question originally can have possibility to get two answers. Two answers are possible. Okay. But as per examiner, we should take it. Okay. So you may also get two answers. Both are right, but I cannot opt up two right answers here. So let me take one answer. So start the poll. So Mohan, Abhinay, he can also be right answer for me. Okay, I will come to that. So let us see. I think 1 minute. Okay. Okay. So these are the 3 byte instructions. So I added 333 and 2 byte instruction. I added 2 to 6. So you get 8 as the answer. So these are the addresses because he has given starting address. So initially stack pointer is 00FF. Your HL register pair is copied with 0107 hexadecimal. Then you see here, this is your memory, for example. Okay, in this memory, this is 0100 like that. At 0106 you have MVI instruction, and 0107 you have 20, and 0108 you have sub instruction. Like that, this is how you have filled this memory. Now as per the examiner, HL is this one, MVI A comma 20, A will be copied with 20 hexadecimal. Then subtract M, that is A will be A minus contents of HL register pair. Contents of HL register pair, that is A minus contents of HL register pair memory. What is HL register pair? 0107. So 20 minus contents of 0107. What is the content of 0107 as per the given examiner? It is also 20. It is 00 hexadecimal. So originally this is the answer, but examiner has used the contents of accumulator when the program counter reaches 1001. Actually here at this time, okay, program counter during T2 itself, PC will be equal to PC plus 1. At that time your accumulator is originally 00 only. Sorry, accumulator will be equal to 20 only. Accumulator originally, this is the original value. Accumulator will be 20. Okay, in the next machine cycle, that is what we call next machine cycle may originally this execution takes place. Okay, but we assume here he said it reaches 0109. So at that, in that way, if you analyze, 20 is also right answer. Okay, so I told already 20 is also right answer. Another way is by the end of this instruction we assume without what we call fetch execution overlap may be internally done, but we assume that this is also right answer, but originally actual sense it is 20 only. Okay, so both can be right answers in this case, because after execution originally this happens in the next machine cycle. So you know this, it is having opcode fetch. In the T2 state, PC will be copied with PC plus 1, that is 0101. At that time, your accumulator is equal to only 20H. Then after completion of this, it will understand it is a sub instruction, and then okay, then it in the next clock it will do the original operation of subtraction. Actual subtraction takes place in the next clock only. Okay, but he has not showed the next thing. So you assume after the end of this complete instruction, what is the answer? We should not take that what we call intermediate result. We should write the final result. So in that way we opted this, but even this is also right answer. Okay, at T2 your PC is equal to, at that time, okay, subtraction not at performed. What happened? Power is not there. Just wait. Okay. Yes. Anuj, correct. So if his terminology is little clear, we can say better. Okay, but you know the concept behind it. Okay. So shall we move to the next question? Good. So consider, yeah, this program may from 1009 onwards, 2 extra instructions are added. That is at 0109 or immediately 40H, and then he has added one more instruction at 0111B, add M. So what is the question is, what will be the result of the accumulator after the last instruction is executed? Here he clearly given executed. Then we can understand execution is completed. Okay. So please tell me here. Here at least if we say like this, instead of when, if the contents of accumulator by the time, if we use the terminology like this, by the time PC reaches 0109, then blindly answer is 20 only. He don't say by the time. When it is 0109, he said. Okay, let's go for this poll. Actually, in the second T state of this, originally that will happen. You need not know it, Anuj. Okay, here he said, in addition, the code exists from. From means what? Location. Location is a address. Here he said clearly, the following program starts at location. Location means what? Address only. So let's start the poll. Okay. Good. So please do it. $79. Finally, Mr. CEO Rishi Kumar, right answer. Is it your original name, Rishi? Right. Mohan. Okay. That is CEO Rishi Kumar name. Mohan, Abhinay, Nishita, Shubham, Suraj, Danpal, Rishi, 3, Harsh, Abhineet. Yes. Okay, good. So here the right answer is very simple. Already accumulator is containing how much? 0, 0. Okay. Then and or immediately you or this all zeros with or 0 or with anything is anything na. So accumulator will be copied with 40H. Then add mm, A will be copied with A plus A plus contents of HL location. Already we know HL location contents is not modified in the instruction. Subtract M is copied in the accumulator. M is not touched. So it will be 20 only. HL is not touched anywhere na. So it will be 20. That is 60 hexadecimal. Good. So let's move to the next question. So with this, I mean, please see, if you practice the questions now, automatically your revision is also completed. Revising the instructions is now easy. Let's go. Read this. Read this question. Where is Aditya? So I think you are happy today because we are doing more number of questions. So let's do it. If you are ready, I will start the poll. Just read the question. Start the poll. Shall I start the poll? Okay, let's start the poll. See, my dear friends, these are the top results. Okay, now it is a simple question. I hope HL should be copied with 9258. Accumulator is copied with the contents of 9258. Then accumulator is complemented. Then what happens? Again, the memory is copied with the A. That is, the contents will be complemented and copy back to the memory. What happened to you, Mohan? You slept or not? Or I am sleeping. Okay. HL is copied to this. M is copied to this, complemented. Then again, A is copied to back to M. That is, contents of 9258 are complemented and stored in the location 9258 itself. Okay. Next, leave it. Right. Read it. Next question. Is this background is good compared to last background? I think lighting is better. Shining. Yeah, it is actually for YouTube. For Chroma Key, we'll use this. So the number of memory cycles required to execute the following instructions: load accumulator. Okay, memory cycles. Okay, fine. LXI comma this one. Okay, good. What would be that? You can easily do this question. Ready? Just how many memory operations? You know the machine cycles I told earlier. Load accumulator mein what happens? LXI mein what happens? Even you don't remember also you can answer. If you understand the instruction properly, you can answer it. I started the poll. Good. Even you don't remember also, no problem. I mean, here from the instruction itself you can do. LDA 3000. So it will do opcode fetch. Then 3000 will be read, that is memory read. Then load accumulator into 3000. Then at the 3000 it will write. For LXI F1 F0. It is a direct loading. Opcode fetch, copy DE with these two, that is memory read. So here 3 machine cycles, here 4. That's what asked. Okay, what is MR? Memory read. Load accumulate. Yeah. Sorry, it's not store na. Memory read. Okay, he asked, clearly listen, he asked memory cycles only. Okay, you don't worry about your write or read. He asked how many memory cycles are required. So opcode fetch is also one kind of memory read only. Yes or no? Job may be stored into instruction register, but originally it is doing same job as memory read only. It is also one kind of memory operation only. So 4 plus 4 and 3, or you know, this requires more time. You see, this requires more machine cycles. There is only one option for that. LDA is more and LXI is less. In that way, examiner helped you, even you don't remember. Next, read this. In 8085, the instruction compare B is executed while the accumulator is less than B. Start the poll. So don't forget your digital after microprocessor. Don't do that. Just practice regularly. At least give some time. Whether it is 15 minutes also okay. Do at least 1-2 questions such that it will make it a proper revision. So share with the learners. So these are the right answers. So Harsh, you entered into second now. Nishita is the only person who answered all 8 by 8 right answers. Good. So compare of instruction may with this answer. This you should answer. Everybody should answer. Yesterday only we discussed. Accumulator is less than content B. When A less than B, carry will be 1 and 0 will be 0. So carry flag will be set and 0 flag will be reset. Yes, today also one problem we have. So the next question is jump not required. We will jump from that. Then yeah, you can do this. The content of register B and accumulator. You want today DPP chahiye to I can provide you. Just remind me at the end of the class. This is already done. Not done here, I think. Done? Okay. If you say done, it is done. Okay. This is a simple question. Try it. Start the poll. Okay. So it is a simple question. What is the frequency time t state is equal to 1 by 5 into 10 power minus 6. Directly seeing this 1 by 5 is give you something as the 2. 1.5 is something as 7 times. So it is a 0.2 microseconds. So 1.4 microseconds is it is 7 into 0.2 microseconds. That is 7 t states. Okay, you divide these two or you will get the answer. Okay, that's all. So now your DPP is done, right? Now we have few more questions also. There is no end for doing number of questions. If you want, we can do it later. Then we start with the remaining group of instructions. So let's start the remaining group of instructions. What are the remaining group of instructions, sir? Branch group of instructions. Thank you, Deep. So your fear will be gone once we do the problems. क्या हुआ रुद्राक्ष? Any problem, Rudraksha? Mega HGS. I'm sorry. Okay, fine. So the branch group of instructions. What are the instructions we discuss here? Very simple. Your program is running like this. Suddenly you jump to some other location. Program is running like this. Suddenly you jump to some other location. It can be conditional or unconditional. What is conditional, sir? There should be some reason. If that reason is valid, I will jump. No condition, sir. When this line comes, automatically I will jump. Okay. So this is what we call branch group of instructions. Okay. Like you want to go out. For example, you are in the home, you want to go outside. Okay. So you check one condition, whether rain is there. Yes, go. Otherwise, don't go. Okay. Is it sunny, whether to go or not? Like that, you can check some conditions. Some persons will check that. Some people don't care. Just time comes, immediately jump. Okay, so conditional is there, unconditional is there. Your program is also like that. Depending on the program requirement, we can go for condition or unconditional. Conditional make it will check if particular condition is true, then only it will go. If condition unconditional may it won't check any conditional, blindly jump. Blindly jump. Jump means go from one location to another location. So even if you don't want positive also, you need to stay home. Okay, so conditional, unconditional. Okay, so listen here. Okay, so your corona will check whether mask is there, yes or no. No. Okay, attack. Yes, don't attack. Okay, conditional corona is there, unconditional corona is there. In unconditional case, whether that fellow is wearing mask or not, otherwise it doesn't matter, attack is done. Okay, so both the cases are possible. Yes, correct, right. Daily, whenever you call, you need to listen that it has become like who is that? Whenever earlier we watched two movies, Mukesh, it became like a Mukesh ad these days. See, it became like earlier we used to watch movies, so we came to different era. Okay, so let's start. So branch group of instructions. In this group, in this group, or let me write right here. These instructions are used to change the program sequence. These instructions are used to change the program sequence by changing who will take care of the program sequence? Program counter. Okay. So program sequence by changing contents of PC. Okay. So this is what we call branch group of instruction. In that program sequence means it is going in an order. Suddenly it will jump from regular location to particular location. Where we use this in your computer, like if else conditional statements. If x is equal to 1, do this job or go to somewhere. If x is not 1, go to somewhere else, continue like that. Some conditional statements, conditional programming loops or jump conditions, we will use it. Okay, so now let's go. So if suppose you take count equal to 5, as long as count is not equal to 0, continue, otherwise go out, like that. So now in this, let's take the example of, right, what are the instructions we are going to study here? Jump, unconditional, next condition, sorry, conditional jump, next PCHL, then call, in that also unconditional, conditional call, then return, unconditional, and also conditional return. And also one more instruction, RSTN. These are the instructions we are going to study in this group. What are they? In this, what is this? Branch control group, branching group of instructions. In this branch instructions, we are reading these kind of instructions. Now let's start one by one. Let's start one by one. Start with which instruction? Let's start with the jump instruction. JMP. Yes, let's jump into jump. You know, earlier there is a jump in one drink is there. Do you know it or not? You don't know. Means I am little older. It's like a mango fruity. Earlier one jump in is also there. Okay. Okay. So first we are discussing unconditional jump. That is JMP 16-bit address. JMP 16-bit address. So here, please listen. Jump to the 16-bit address. When 8085 executes this instruction, it moves its program execution to the 16-bit address given in the instruction. Okay, so for example, see here. Let's say jump. No condition is there. Jump, that's all. Blind jump. Okay, so here let's write that address. Put say 8000. So what is the meaning of 8000? Okay, so now see here. Opcode fetch, memory read. Then the program will move to 8000. Okay, so here it will load to which registers? Who will take care of this? W and Z. Then your PC is loaded with this location. Then program will go to 8000. Okay, so generally we say PC is loaded with 8000. Say for example, it is in 2000 location. Okay, so here it is not directly loaded to PC because PC is needed to read these up to this end. PC is required. Then this value will come. Then you will go to 8000. I will show you how it will do, but first tell me how many bytes instruction. How many bytes are required here? Good. It is a 3-byte instruction. It's a 3-byte instruction. Next, second. How many machine cycles are there? How many machine cycles are there? 3 machine cycles are there. Opcode fetch to memory read. Now, total how many t states? 4t plus 3t plus 3t. Time कितना चाहिए हमको? 10 t states. Then, what is the addressing mode? Tell me, what is the addressing mode? Yeah, everybody comment. What is the addressing mode of this particular instruction? What is the addressing mode? Any other answer? Very good, very good. It is immediate addressing. Because what is direct addressing mode is we should read data or write data in that memory. We treat whatever the data coming as an address and we go to that address and read the data. That is direct addressing mode. Here operand is at that address, then it is direct addressing mode. Here operand is not at that address. We are directly going to that address. So immediately number is available. Your whatever registers are loaded with that and go there. So what is this addressing mode? Immediate addressing mode. It is not direct addressing mode. You are not going to that address and read any data. Here you started execution of the next. Okay, this instruction is just moving to 8,000. Here it is reading the number 8,000 immediately. It is not going, it is not reading this as an address and go to that particular location and read the data from that location. Here operand is not at 8,000. If operand is at 8,000, it is direct addressing mode. But here immediately this number is available. This is loaded to WZ and we jump to that. So immediate addressing mode. Here there is no flags affected because you have not done any arithmetic operations. Shall I move further? Value of PC I will explain, don't worry. Okay, so I know you will have some doubt. Let me give you the internally what's happening. It is immediately loading the data here and immediate what is direct addressing? Direct addressing may you have operand at the memory location. Here you don't have any operand in the memory location. Here we directly load this, we go this. So immediately the number is available. We are loading that number directly. Whatever required for you is available immediately. I did somewhere. Let me check where it is. I think I loaded something wrong. Okay, let me load it. Just go through it. Okay, see here. For jump to particular address, what happens? This is for jump instruction. So first opcode fetch tak it is same. After opcode fetch, first the lower address, whatever the lower address is there, that will be loaded into Z register. Say in this example, 00 is there, na, that number is loaded into Z register. That number is loaded into Z register. Up to this clear? Second machine cycle. Next. Third machine cycle mein, the second number is there, na, that will be loaded into W. That will be loaded into W. So originally PC is incremented by 1 here also, because computer okay, will generally have up to the next. But now PC is not originally loaded with 8000. Who is having 8000? WZ are having. So in this case, you observe in the opcode fetch of next machine cycle, next instruction, PC will not be there. Who will be loaded into the address bus? Directly WZ will be loaded. So not every time PC will be loaded. I already told earlier also. Sometimes your W and Z also will take care of this. Sometimes your W and Z also take care of this. Okay, so here, because it is a time waste to store this in first WZ, then give to PC, PC give to address bus. It will waste CPU time. CPU time is very important for us. So directly give WZ to the address bus itself. Then in the second D state, generally what happens, PC is incremented by 1 in the second D state of any machine cycle. Now, during that time, PC is loaded with directly 8001. Here it is 8000, for example. Here it is loaded with 8001. Understand? This is what we call your fetch execution overlap. Internal happening. Internal happening. Okay. Next. Yes. So shall we move further? Sir, we are not concerned about what is stored in 8000. Yeah, that is you are concerned in the T3 state here. That will be taken care by next instruction. It is not the job of jump instruction. That is the opcode fetch of the next instruction. In the T3 we will be reading that. Okay, you see here that and in that address, whatever there, it will load to address bus. In the T3, address bus will give you instruction register. That will happen parallelly. That is not disturbed at all. Only address bus is given with 8000. Then job is done. 8000 mein whatever is there, that is the job of next instruction, not for us. Okay, next move. New slide. So now what I want to give, earlier what we discussed is conditional jump, unconditional jump. इसमें कुछ condition satisfy होना नहीं चाहिए. You don't need to satisfy any condition there. But now you need to see what we call conditional jump. Let us see what is the meaning of conditional jump. This is no need to remember this, just for your understanding I am saying. Okay, so this is the opcode of conditional jump. Here in place of CCC is there na. It is the byte 2 and byte 3 of the your total instruction. Okay, so CCC ka place mein what you get it is this you get it. So you can check the condition is true or not for 8 possibilities, because 3 bits are there na. 3 bits are there. How many combinations are there for me? 3 zeros to 3 ones. 8 will come. So 8 combinations. So here flags are to be checked. whether the carry is 1 or not, 0 is 1 or not. So I have 5 flags. So I can have 10 combinations, but I have only 8 possibilities. So I need to sacrifice one. Correct or not? I have 5 flags: carry, auxiliary carry, 0 flag, parity flag. What is that? Sign flag. So I can make the code like this. When sign flag is 1, do this jump. When sign flag is 0, do this jump. Both are possible. What are they? When sign flag is 1, jump. When sign flag is 0, jump. Both are possible. Sign flag is 1, you can jump. Sign flag is 0, you can jump. Both are possible. Okay. So now here, what is that? For, like that, I can make 8 combinations only because 3 bits are there. Because these are used for the opcode generation. It is not in your hand. Only 3 are there. So you should sacrifice one flag compulsory. So that's why in 8085, conditional carry, conditional, what we call conditional jump is available for 0 flag, carry flag, parity flag, and also sign flag. But not for, yes, auxiliary carry is not there. That is the reason auxiliary carry is not present. Okay, you understand now? Because you have only 8 bits for opcode, you have 256 combinations are only possible. In that only you should adjust everything. So here you have only 8-bit combinations. So any conditional is not available with auxiliary carry. Okay, so it is less frequently used. So examiner, what not examiner? Always we are getting examiner in our mind. Manufacturer has neglected, or designer like you have neglected that. So listen here. What I want to say, right? Conditional jump. Conditional jump. Okay, jump if condition is true, else continue. Okay, so like this you can say, this is what we call decision box, right? Condition is equal to true. If it is S, jump. No, continue. Okay, so here you have program counter here, then it is a PC plus 3, it will go. Not PC plus 3 in one at a stretch, because it is a 3-byte instruction. I want to say that it will go to the next instruction. So here in 8085, 8 conditional jump instructions available based on flags. So let us see that. So what are the instructions are there? Jump JC. JC means jump if carry flag equal to 1. JNC. What is that? Jump if no carry. That is carry equal to 0. So you can make the relation like this. Jump when carry is generated. Jump when carry is not generated. Similarly, J, Z. That is jump if 0 flag equal to 1. Next, JNZ, that is jump if, sorry, 0 flag is equal to 0. That is jump on no 0, jump on no carry, jump on carry, jump on 0. Okay, so 4 are completed. Jump parity even, that is jump if parity equal to 1. Jump, that is even. You can code it. You remember like that. JPE. Whenever you see JPE, jump if parity even. JPO. Jump if parity equal to O. That is odd. Jump on positive. Jump on negative. That is jump if sign flag is equal to 0. Jump if sign flag is equal to 1. That is positive and minus you can see. These are the names given by your what we call designer. So these are the 8 variations we are having for jump instruction. Okay, so all of them are 3-byte instructions only. All of them are 3-byte instructions only. Is it okay? First point. All of them are 3-byte instructions only. Very good. Next. What it is having? How many machine cycles? 3. But there is a different case. 2 machine cycles also possible. Here, it will not jump every time. It will not jump every time. It will jump only when condition is true. Jump only when condition is true. Because of that, this is if condition is true. Here, if condition is false. That is opcode fetch plus 2 memory read, or if condition is false, there is no use of reading the address now, so it will not read the address completely. Whenever it understands it, condition is not true, why to read, why to waste your time, it will stop. So it is 10T states or 70 states. Wait, but how it will check condition, people? How it will check the condition? No flags. What is the addressing mode? Same story. No flags affected. So earlier it took me around 2 hours to finish some 4-5 instructions. Now in single slide you are able to lead these many instructions. Okay. So now let us show how this execution takes place in the computer, like your machine cycles. Then it will be more clear. For your doubt only I answered, Amarendra. Just to see this, then you will understand. Mark, just wait. We don't know the time. Depends on the topic we see. Okay, my dear Amarendra, Bahubali. Okay, right, people, correct. So see here, 9:30 is a time, Surah. Now it is 8:30 na, like that if you add 1 hour, you get 9:30. Math special class. You are plus subscriber. Why are you worrying about special classes? Okay, now listen here. Here first microprocessor will read it is a jump if condition is true. So normal 40 states are required. 40 states are just to opcode fetch and decode only. Fourth state is to decode it. Okay. Then it should check it should check whether it is true or not. If it is true, it should read the next 2 bytes. Two methods are there. See here. You can design two ways. First method is okay, 4 T states, and now check that is extra some 2 T states are required. Then if it is true, okay, 3T jump. False, directly continue. This is one method. Say it may require 2 or 3 T states, forget about it. Now another way is you check parallelly with the next memory read. Both happens parallelly. If it is true, continue. If it is false, jump to next. Which one is safe? Which one is computer point of view efficient? Tell me. First method or second method? That's all. So manufacturer also made the same thing. So he assumed that it is true. He is doing this parallelly. He is checking also. Okay, why to waste this time? Because sometimes if it is not true, your time is wasted. If it is not true, okay. If it is true, your time is wasted. Instead of that, by the side parallelly, you do the memory read operation. And is that data is getting wasted, you will be storing that in the temporary register only. So no problem for us. See here, machine cycle 2 mein normal memory read it will do, but where it is reading? Where it is reading? Temporary register Z. It is reading into temporary register Z. So no problem. So here it condition is true, then go to the machine cycle 3. Otherwise, go to the next. That is, the program counter will be incremented by 1. That story will be done as it is. Here, please understand, PC is not incremented by 1. Already it is incremented by 1, and another increment means it will neglect this. Okay? Understand that PC is originally incremented by 2 in that case. Because if condition is not satisfied, we need to skip this now. So this is how you need to make the efficient design. So why to check the condition? Condition check it parallelly. Do it assuming it is right. Then no time waste for me. When condition failed also, for checking the condition anyway, the time is required. At that time only I am doing this job. So now it is clear, even condition is not true, why to waste one memory? It is not wasting, it is saving our time. Do we need to remember all these things? Remember means logically remember. You observe here, same thing is happening for every instruction. You should know what's happening, that is required. So for example, you have done previously questions. For that, you need not remember anything. Automatically, you will be able to do it. Just revise our notes, that is sufficient. No need to mark up, that I can say. Okay, you should know what's happening, that is important. Good, let's move. Too much not. Complete instruction set you should know. Okay. There is nothing to remember here when you see. This is simple. When you see JC jump on carry. It is simple as remembering ABCDs. J for jump, C for carry. Yes. In that 246 also 74 only varieties. Only 74 varieties. In that JZ, jump 0, jump no 0. You see the name, automatically that will come in mind. Which are similar? Please tell me, Shivam. No single instruction is similar. Yes. If you see the program like previously you did the questions, now automatically you recollect. Shivam, tell me, is there any instruction which is similar? If it is similar, how computer will, what we call, execute it? They are not same, you are saying, I understand, but not similar. The name will give you the different. Internal operation, you forget, no problem, Aditya. Those are just for your understanding properly. You are reading all 246, Amarendra, why not? Okay, let's move. Please understand here, you don't remember every single point here. Understand the logic. Okay, this is happening like this. Shivam, first you come in time here. You came at 8, you are asking all the questions. First come on time, then you can understand all the things. Okay. First come on time and regularly. Oh, you made what we call cooking? Nice. But you can listen to the lecture parallelly. What is the problem? You can join and you can keep there and you can make that. Okay. So every time I am saying again, don't worry to remember the things. That will actually that will only okay make you get you that fear and automatically you stop remembering the things. Take casually your memory. You believe in your memory. It is very high, better more than your microprocessor. Okay. So don't believe in your memory. Okay, it is a logical memory. Once you see the instructions, automatically things will come out of your mind. So if you want to remember intentionally, it won't happen. If you want to remember intentionally, it won't happen. So Aditya has switched on the grinder, I think, maybe. You switch on the oven. Right. So that is about your jump instruction. Here, again, that story is same if you want. If I give too many things, you are worrying about remembering. Don't worry. Maggie. Okay, with the same story. WZ is copied with the story is same. Okay, so let's move. So like our Kharagpur college mess. What I'm doing is changing the theme. Right. So the new slide. Right. Okay, आपका job. So let's continue. The next instruction, call instruction. So the next instruction is call instruction. Call instruction is used to why it is used? To call. Yeah, Ruchita, after lockdown, everyone knows cooking. So call instruction is used to call a subroutine from main program. Okay, call instruction is used to call subroutine from a main program. Okay, suppose your main program is running. From that call comes, then computer will go to there and it will do the sub like function. Call a function in your C language. So it will call that function, complete it, and come to main program. Na? Similarly, it can be used to call a sub program from the main program. Okay, when call instruction is executed, when call instruction is executed, the content of program counter copied into top two locations of the stack okay, and program jumps to the address specified. Wait here. There is a difference between your jump instruction and call instruction. What is the difference between the jump instruction and call instruction? Jump, once you jump. Okay. Yes, Samarendra, correct. Okay. Once you jump, you cannot come back. Like if you come out of the home, okay, if you return back, if there is a possibility to return back only when you remember your home address. Yes or no? From your home you came out, you can go home only when you know your home address. Similarly, computer also, it comes out of your main program, and when it is jump, it cannot return back to the main because it is not saving the address while coming out. But call, it is saving the address while coming out. That is what it is saving, because the PC will contain the address of the next instruction address is present in the program counter only na. So PC will store it. PC will be stored in the where top two locations of the stack. That is pushing into the stack we call. So when you come out, you can read that and go out. I mean, you can pop it and you can read the top two locations and you can go back. Okay, so here return instruction is used to come back to main program. Return instruction can be used, a written instruction is used to come back to the original main program. Okay, yes, not like C. C is like this. Okay, because your C comes from this only. I mean, this is the main with respect to program what computer. Wait, Aditya, don't worry much. Here, for example, you said call. This is your first PC. PC plus 1, plus 2, plus 3. This PC plus 3 is stored into stack. Then when you return, you go to PC plus 3. That is where your next instruction is present. Okay. So where we are? Right. Return instruction is used to come back to main program. When return instruction is executed, when return instruction is executed, one minute. Yes. It is cool now. Okay. Even it is not cool, we need to be cool. It is happening in some other room, I cannot do anything. Even if I shout also, it will be recorded in video. I don't have any option. So when return instruction is executed, then PC copied with top 2 locations of, yes, Aditya, definitely. I'm not what we call who Rishi or something, what we call Maharshi, like that. I'm not Sadhu kind of guy. Sometimes it happens. So copied with the top 2 locations of the stack. I mean, if you conquer that anger and all those things, you may become that sage. Okay, so that requires some time. Over a period, maybe we may be able to win over the anger. Either two cases are there. Anger may win you, or you need to win over the anger. Okay, who will be the succeeding? That depends on the situation. So let's go to microprocessor class, not this philosophy. So when return instruction is executed, the program counter copied with, is it that much serious in the network class, Ruchita? I didn't shouted on anyone, I think in the, maybe my face is serious because of what we call morning face, that is. Why to poll? If everybody said I am anger, I need to worry about it. Okay, so maybe it is a tired or something else, maybe looking like serious. If you are there, it will be more anger. Aditya? So when return instruction is executed, the program counter is copied with the top 2 locations of the stack. Okay, so that is about with the call and return. Okay, so generally return should be followed by call. Okay, call instruction followed by return. Our subroutine should have this return instruction. So listen here. When you call, what happens? No problem, leave it. So you take the main program, you call the subroutine. In the subroutine, okay, you are doing some job, you say return, it will come back. Okay, so now see here. This is return. Actually, today I think I switch off this fan. Okay, because of switching off the fan, I thought some noise is coming. That's why I switch off. But because of that, outside noise is coming inside. Okay. Now see here. The main program is there. Subroutine is called, completed, return, come back. Okay. Here you are storing only PC. But if you are a healthy programmer, not physical health, not physical health. So if you are a good programmer, okay, if you are a good programmer, generally in the subroutine, what you need to do is store all register, at least accumulator, etc., into stack and do your program part. Then again, return what we call pop your accumulator and all, and then go back. That is a flag, your accumulator, whatever is there, na, that will be stored in the stack before doing this subroutine, because that subroutine should not disturb its previous values of the accumulator, etc. Maybe some program is running up to this. Okay, so healthy programmer will take care of those things also. But you don't mind about the other things, you are happy to destroy the others programs, then you not worry about those things. So it comes, you do your job, done. Okay, so now let's go to call instruction variations, like jump instructions. Okay, like jump instructions, call instruction variations also, let us see. So right, right now, unconditional call. What is unconditional call? Shall we do some problems, or you need a theory? Or let us complete this, then one problem is over. Questions are required. But we started now. Okay, let's complete this. Okay, let's complete this unconditional call. That is a call address. Say, for example, you say call 2000. Then what happens? It requires opcode fetch. Then I'm sorry, why I'm writing opcode? Say, for example, call 2000 is there. Okay, this is opcode fetch, memory read. Okay, so then 2000 will be loaded into our favorite Z and W registers. Then it will do the operation. So how many machine cycles are required here? How many machine cycles? Firstly, it's a 3-byte instruction, no doubt in it. It's a 3-byte instruction. How many machine cycles? 3 machine cycles? Wrong. Wrong. You are seeing only this part. You need to see something else also. Program counter is to be stored into stack. Program counter is a 16-bit, is to be stored into stack. That requires 2 extra machine cycles. Total 5 machine cycles. Very good. It requires 5 machine cycles. Okay. So that is how you need to remember some things at least. Okay. So if you here, no need to remember about 5, you just remember call address, that's all. Just what it is doing, if you know it, you can understand. So sequence I will show you. First opcode fetch, then stack pointer is decremented by 1. Okay, then your register pair is there na, lower order, sorry, your Z is copied with not RP, address lower byte. Okay, that is a 16-bit address na. In that lower byte is copied. Here your PC will be, I'm sorry, incremented by 1. Then it will go to third one. Okay, so here also PC will be incremented by 1. That happens every times. Then it will go to W is copied with address higher byte or low, say, least byte, highest byte, higher byte. Then now your PC will be incremented by 1. Okay, now this is the story happens internally. Now one more thing which happens here is this program counter low and program counter high will be copied into top two locations of the stack. So the contents of the stack pointer will be copied with the program counter lower order. Okay, so 1 minute, it is push B. First B will be stored, then C. Okay, next. Then we decrement the stack. I told you na, you should decrement whenever you write into the stack. Then again the stack pointer, the contents of the stack will be copied with your program counter lower order address. Then next, this is next instruction is address bus is copied with WZ. In the first T states, and PC will be copied with WZ plus 1 in the second T states. Yes, every time, please listen, every time, whenever you want to write it into the stack, here memory write operation. Here also memory write operation. This is memory read operation. Okay, this is opcode fetch, you see. So whenever you want to write it into the stack, first you should decrement. I told in the starting basics, stack always points to the, what is that, filled memory location. Whenever you want to write the data, decrement, write it. Decrement, write it. So stack operation mein first you should decrement. This is called pre-decrement. Okay. So push operation is, push means what? Writing into stack. If you want to write something into the stack, it is a pre-decrement operation. First you should decrement the stack pointer, then you should write it. First you should decrement, then you should write it. Okay, push operation, whatever you can call, is a pre-decremented operation. It is a pre-decremented operation. Okay, so now next, how many machine cycles, everything, let us copy it. Push only. You are writing na. If you are writing, it is push. If you are reading, it is pop. Okay. It is push only. When you are writing, push operation. When you are reading, it is pop operation. Okay. Any other doubts, please ask. Okay. Some people who is that Aditya, why it is here only? Where you do it? Before coming here, you should complete this and come. Okay. So for that you don't have any other machine cycle. You should do it in the during opcode fetch only, because this memory read, memory write are fixed 3 machine cycles. In that already PC is doing it. Okay. It is fixed. So here the computer designer has made this like this. Because of this, here you require extra 2 T states. Because of this operation, it requires extra 2 T states. Is it clear, Aditya? Okay, fine. So during this period, your PC is not involved. Who is that? Address bus is copied with your program counter, all those stories same. So now listen here. How much time is required? Everything. Let us do it now. Please see. What is that, Amarendra? The decreasing address of the stack to store in new position because towards the top address decreases. I understand what is the meaning of towards the top address decrease. I didn't understand. See here, in your stack, it is like this. This is what SP is storing. SP is pointing. When you decrement, it will go to the next location. Here, it will write your data. It always point to the top, which is filled location, not empty location. This is the syntax followed in 8085. Okay, now how many byte instructions? It is a 3 byte. Next, how many machine cycles? 1, 2, 3, 4, 5. 5 machine cycles. Opcode fetch to memory read to memory write. So here 60 plus 2 into 3t plus 2 into 3t, that is 18 t states. This is the longest instruction in your 8085 with respect to duration. See here, Aditya, I will tell you the strategy. First, follow the classes. We will do the questions in the class. Do all previous questions. Whatever the required things for your examiner already will be in your mind. If they are not in your mind, you can find from the notes. After that, if you have time, you remember whatever you want extra. Okay, don't worry about remembering the things, and don't throw this to the other people in the class also. You are worrying and you are worrying the other people in the class also. Your worry is starting spreading to the other people also. So generally I suggest avoid the negative things. So remaining people, okay, so some people says it is difficult to remember. You don't take it into your memory. Up to now you are happy, you continue to be happy. This is the thing happens in your preparation also. Okay, this is the thing happens in your preparation also. Some student, you are happily preparing, some student will come, he will bring you one new question to you. You have not prepared that. Okay, so this fellow is preparing this much, I have not prepared this, so I am not preparing well. All these things will come. Okay, don't listen to others. I'm not saying Aditya, generally I'm saying this example. Okay, so now see here, in your preparation also some people will come to you and he will say again these things also. It is very difficult to do this subject. Automatically you also get that in your mind, this is difficult subject. Not I'm saying micro, any other subject. So you follow your own timeline and be positive. Whatever you can remember, that only you can remember. Whatever you do, it is of no use. Okay, so see here, it is the longest with respect to duration. It is the longest with respect to duration. Next, what do you want to say? Addressing mode. What is that addressing mode? Tell me the addressing mode, guys. Immediate? Direct? One more addressing I am waiting. I am waiting for one more addressing from you people. There is no implied here. I understand that you don't say that answer. Yes, it is immediate and also register indirect because stack is involved. Pointer concept is coming. Whenever stack is involved, pointer concept is there. So both are correct here. So no flags affected. No flags affected. So that is about your what we call this one. What is that? Call instruction. Here, whenever 60 states comes, I always give you the reason for 6. Remember that. Whenever 6 comes, I will tell you why 6. That extra 2 T states are required for what reason. This you should remember. Okay, this you should remember. So for today, we can end the class. Tomorrow we discuss conditional call, all those things. Okay, these questions are there. You can practice now. What are the questions I have given? I mean, other than what we have done, now you can try this. Few questions, not all. Tomorrow I give you some 40 questions. You want now? Even I give now also, it is of no use because push instruction, etc. to be completed. Yeah, most of the cases, Aditya, that is also true. Stack concept, don't worry, because we discuss push and pop instruction, then we discuss it again. Tomorrow is doubt session. At night, tomorrow is doubt session. So first DPP, second DPP, all DPPs, we do it tomorrow. Then we discuss this remaining part of the instructions also. Okay, when is the quiz, Aditya? Like a quiz, we can do it if required. Let me check if I can get one more DPP. How I think. Just wait for 1-2 minutes. I will give you that. Okay. So this you can use up to the, I mean, total end of the class also. I am loading it. Mega quiz is there. I need to make the paper then. In doubt session, we can take it. What is there? 9th, na, I will tell you, don't worry. Yeah, it will be digital and micro only generally. We have time. So you are asking DPP, I gave the questions. 50 questions I am loading. You can try. You can see Aditya, if possible, we can come. Okay. So you can try these questions, whatever possible. So it will take out your fear also. Bye bye. Good night. Thank you, guys.